Let's take another look at this example, but now with different assumptions at the start. So we still want to find our output voltage and diode currents, but let's say instead of making the assumptions we did in the previous video, let's say we look at this circuit, and again, we're trying to make an educated guess. So we see we have +5, which is indirectly connected to our P side of D2. So let's say D2 is on. And let's say we kind of look at this quickly and we say, all right, well, the inside of this diode is indirectly connected to a negative voltage. So that should be on as well, because remember, we're told that this input is 0. So let's go ahead and assume that both of our diodes are on. And as we said last time, we need to make an assumption about our cut-in voltage and our RF. So we had assumed that this was 0.7 volts for V gamma, and RF is 0. So this time we're saying that we're assuming both diodes are on. So D1 and D2 are on. So we've made our assumption. Now we need to analyze our circuit, and then after that we're going to check our assumption. So let's go ahead and paste our circuit here, and because both diodes are on, we're going to replace each of them with a battery or a constant voltage supply. And the orientation is such that the positive is on the P side and the negative terminal is on the N side. So we get something that looks like this. And so again, our diode voltages, which I didn't have written above, aren't going to change polarity. So we have V gamma here and V gamma here. We're assuming they're the same type of diode. Okay, so what we notice from this is this actually makes V out really easy to find, because remember that our VI is 0. So what we have is 0, and then we subtract V gamma to get to V prime. We add V gamma to get to V naught. So essentially our V out is equal to V in. So V out is equal to VI plus V gamma minus V gamma. So it's just equal to VI, and in this case, that's just equal to 0. So that would be one part of our solution. But, of course, we need to check our assumptions. So need to check our assumptions. And so in order to help us do that, let's define some currents in our circuit up above. So let's define our diode current. So remember, directions should be in the arrow, in the current directions should be in the same direction as the arrow of the diodes. So we have ID2 in this direction and ID1 in this direction. We can define our resistor currents the same way as we did in the previous video, so IR1 and IR2. Okay, so now we can use our circuit analysis to check our assumptions on our diode states. So what we can do is we can start by noting that IR1 is still equal to IR2 because we only have one path that the current can flow here. So let's say IR1 is equal to ID2, and now remember we just said that our V out is 0, so we can use Ohm's law to find this current IR1 fairly easily. So we can say that this is just equal to, well, in general we can say this is equal to V plus minus V out over the 5 k ohm resistor, but in this case that's just 5 minus our V out of 0 divided by our 5 k ohm, which gives us 1 milliamp of current. Okay, so this is our ID2, and we assumed our diode D2 was on. We have a positive diode current, so that means our assumption is good. So D2 assumption is good. All right, so now we need to check our D1 assumption, and we need to do that by calculating the diode current D1. Well, from KCL at this node here, we can see we have ID1 and ID2 coming in and IR2 coming out. So what we can write is if we want ID1, we can say ID1 is equal to IR2 minus ID2. And of course, we already know that our ID2 is 1 milliamp, so now we just need to figure out this IR2 value. So we can do that using just our essentially KVL and Ohm's law here. So we know the voltage between the two. So let's come back down here. We can say for IR2, this is equal to V prime minus V minus divided by the resistance of 10 k ohms. Now in this case our V prime is going to be negative 0.7, because as we start here, and you can think about this from either side, the left at VI or the right at V out, we start at 0 and then we drop 0.7 and we're at V prime. So we have then negative 0.7 for V prime minus negative 5 divided by our 10K ohms gives us 0.43 milliamps. Okay, so now we want to put this value in for our IR2. So we get that our ID1 is equal to 0.43 milliamps minus our ID2, which is the 1 milliamp we found previously. And we see that this gives us negative 0.57 milliamps. Okay, so now coming back up here to refresh ourselves, we assume that D1 is on. And so of course, remember our diode IV curve looks something like this. So we have some small negative current, and then at V gamma it kicks in. So if we've assumed that our diode is on, we're assuming it's somewhere here, which means it should have a positive current. Of course, this is a negative current, so that means our our D1 assumption is incorrect. Okay, and of course I should be more clear here. Of course, we're using our piecewise linear model. So what this looks like is it's really something more like this. In our case, we're assuming 0 until we get to V gamma, and then once we get to V gamma, we're just assuming a constant voltage. So again, we're approximating, but we're making a good approximation for most cases. So what would we do if we ran into this case? We see that we have an incorrect assumption. So what we would need to do is make new assumptions and reanalyze. So make new assumptions and repeat our process. So we analyze and then we check our assumptions again. Now obviously, again, we talked about you can make educated guesses as to which ones are on and which ones are not. As our circuit becomes more complicated and we add more diodes, this becomes very tedious. So for more complicated circuits, we talked about using computer simulations, so something like PSpice can be very helpful. But again, if we just have 1 or 2 diodes, well, 1 of course is easy, but just 2 or 3 diodes, then it's manageable by hand. If you want some more practice with multiple diode circuits, you can look on page 102 and 103, and there's an example there where you can get some more practice.